Great, thank you very much. Well, I'm really happy to be here. I know some of you, and I know some of your names, but haven't met you yet. And some of you I don't know yet. So I'm looking forward to changing that. I've been on your mailing list, and every Thursday when I get the email, I'm like, I need to get over there. So I really have to next year make a plan to put a crowbar in my calendar and hold the time, because every talk was super fascinating. And so I'm going to be telling you a little bit today about some work that I've been doing with a variety of collaborators. And so you'll see some names on the screen as we go along. But I just wanted to give you more of an overview, just because I think there are a few different legs of what we're doing that may be interesting to different folks here. And so I'm just going to give you a really brief overview of some of the stuff we've already done on collective intelligence that has led up to some current projects. One is really sort of thinking about what makes up, well, all of it really is about what makes up collective intelligence. And the first project I'll just probably more briefly go over is looking at it more from like a psychometric perspective. If we have measures of it, do they sort of cluster in ways that support the emerging framework we have for how you build collective intelligence? And then as we go into applying this, looking at some of the things we're trying to do in detecting collective intelligence for the purpose of maybe devising strategies where agents could either diagnose or even intervene to help teams actually collaborate more effectively. So that's the basic agenda. And my main goal is to both let you know what we're doing, but also hopefully make some connections. If there are any of you working on things that might be related, I would definitely love to hear it. Have you come talk at our lab or connect with some of my students, et cetera. Okay, but just to give you, sort of like where we're coming from, so many of the collaborators in my lab come from more of an organizational behavior background. I'm at Tepper, although we collaborate with folks in a variety of disciplines. But many of us are coming from this perspective that, okay, human beings, since the beginning of humankind have needed each other, because we can't do everything we need to do by ourselves. So there's often, a task you need to do. Either physically you can't do it. Like I have kids, I have boys, so I'm always making them help me lift things and whatever, right? Because I can't do all of these things myself physically. Or there's knowledge interdependence. I'm here to find out if there's some other folks who have ideas or skills that might help me do my research. And so we need each other. And in order to be able to survive in the environment together, then we have to kind of figure out ways to coordinate so that we can help each other fill these needs, and to manage the uncertainty that we might have around when we will need these resources, right? So, you can look over a variety of cultures, how they solve this problem of how we need to coordinate what we're doing and sense changes in the environment so we can respond and hopefully together survive, more happily than we might otherwise. Well, so the way in the business school world we start thinking about this is in an organizational context, right? So organizations need to manage these interdependencies. They need to manage resource uncertainty. They need to adapt to changes in the environment. And historically, especially thanks to, work by this guy, and I think I'm contractually obligated to make some reference to Herb Simon in any talk I give, but he was, one of the main drivers of this idea that we could enhance collective rationality by organizing people into these functions, into these roles, into these routines that would take care of these basic needs in an organizational sense, right? So that's another variation on how we manage, these interdependencies. And so for many years, we've been, teaching business school students and other leaders about how you can use some of these ideas to make organizations more rational. But alongside a lot of these practices, there have also been continuously changing factors in the environment. And a major one is the growth in information volume. And so, we see this exponential growth in how much data is available. And when we look at the connectedness across the world, what we've seen is also information interconnectedness has continued to grow, at a similar rate. And even I think it's important to put this in the context of other forms of interconnectedness, such as trade interconnectedness, which has not grown nearly as quickly. And you see more blips, due to things such as COVID, but information interconnectedness continues to grow. And the reason why that is an important consideration here is because it means that it changes the way that we work because of all of this information and all the interconnectedness. And so, whereas, it used to be the case, if you went to the hospital, say in the 70s, you might have a couple of people who would help manage your case while you're there. But now on average, when patients go into the hospital, even if they don't have surgery or something super, complex like that, they still have on average 20 different providers that are part of their care while they're in the hospital, in part because all of those people are more and more specialized to deal with the information volume that is involved in the different aspects of patient care, right? And so that increases the complexity of that care. We see this in other industry as well, whereas people used to just kind of go to work and do their job. Now everybody's on teams and everybody is on many times more than one team. And so in the 70s, less than 10% of folks in industry, whether you're talking about manufacturing or even retail, were working on teams. Now over 75% are, and most of them are working on more than one team. And that again is because we have all of this information interconnectedness, and so we need to integrate it. And so we end up creating these teams as a vehicle try to manage and connect the dots, if you will. But what this means is that many of us have calendars that look like this, right? As we're working on all of these teams, I have to thank Pranav Gupta, my former student, who's now a professor at University of Illinois. This was his graphic, but it just, it looks like my calendar in real life. And so while we'd love to design organizations that look like that and function this way, the reality is they are look like this and function this way. And so the way that we can bring about rationality, given all of this complexity, really is changing. And so trying to capture how that is changing and how we might proactively understand it so that we can better help groups and organizations be rational is one of the interests we have, certainly in my neck of the woods here. And so one area that we've been looking to and thinking about ideas and theory to guide our approach is the literature on intelligence, because for over a century now, researchers of individual intelligence, and now, as you all well know, various other forms of intelligence, have looked to this as a concept for understanding how an entity, an individual, machine, group of individuals now could perform a variety of tasks across different types of environments. And so many people are familiar with individual intelligence and intelligence testing. If you're in any formal educational environment, you've been subject to some form of an educational or an intelligence test, which the literature, has demonstrated again for about a century now that this is very predictive of individual future performance over a wide range of tasks in a long period of time. So it's this basic capability that enables somebody to adapt and perform. So in our work, we have been looking at this in the context of groups, of collections of individuals. Is there a collective capability that is separable from the ability of the individual members? A collective capability that enables some groups to perform well, to make better use of the skills, the attentional capability, the effort of the individuals in the collective to perform a wide range of tasks. So that's what was the thing that instigated, the question that instigated our work on collective intelligence in human teams. Because at the time that we were starting this, the idea was if you wanted an intelligent team, you got intelligent individuals, and that's how you made an intelligent team. Because the idea was also that teams were set up to do different tasks. Like a team couldn't be intelligent in the sense that I'm talking about, where a team would perform at a high level across many different types of tasks, because the thinking at the time was guided by framework such as this one, which said, okay, there are different types of tasks. This is one taxonomy promoted by McGrath in the 1980s. And they said, okay, well, if a team is set up to do a very creative task, they're set up with, in one way with one set of routines. If they are trying to carry out a very detail-oriented, psychomotor task, they're set up with a different set of routines and processes. And so this idea that you'd have an intelligence that would enable these teams to flow across these different kinds of tasks was kind of counter to this notion that you have these different processes. And so you try to optimize a team's structure so that it could perform the kinds of tasks that it was assigned to perform. And so we were sort of challenging that and saying, well, you know what, we think there might be a capability of certain collections of people to perform a variety of tasks. And so to test that hypothesis, we brought teams into our lab and we gave them different task types sampled from some of these taxonomies. And just cutting to the chase, we found support for this hypothesis that there are some teams that are consistently good at performing across these different task types. So creativity tasks, more detail-oriented psychomotor tasks, mathematical tasks, writing tasks, visual tasks, et cetera. And when we measured their collective intelligence based on how they performed across all these tasks, so kind of an IQ test, but for teams, we could then predict with a pretty high level of accuracy how they performed when we brought them back in the future to do a more complex, multifaceted sort of video game scenario. And we could predict much better than knowing the IQ of individual members. So it suggested that this notion that there's a capability of a group, of a collective, to work together on a range of tasks, and that capability is not the same thing as simply just the intelligence of the individual members. Got some support from these initial studies, and we replicated it in a second study and published it in Science in 2010, where again, a measure of collective intelligence in the team was a much better predictor of future performance than knowing the average or even the maximum intelligence of any individual member. Sometimes, especially again, in my neck of the woods, I get asked about leaders. Well, gee, if you just have one smart person, isn't that what you need? And that could be the leader and they could tell everybody what to do. Well, it turns out that that also is not as predictive as this capability of the whole group to work together. Okay, so support for this general notion, which led us to then start to really explore, well, what is it that predicts collective intelligence? If it's not just all about individual intelligence, what seems to at least be associated with its emergence? And so we've done a variety of studies in that time. I've had the benefit of collaborating with a lot of really different and interesting folks that have taken us in a few different directions. And so I'm just going to summarize some of the big predictors that show up the most frequently. There are a few different forms of diversity that have shown up in our data as consistent predictors of collective intelligence. One predictor that takes different shapes in different studies. And so this is one data set that accumulates data across about 600 teams. We've seen various shapes of correlations with the proportion of women in a team in collective intelligence. In our original study, it seemed more like a linear relationship where more women meant more collective intelligence. In this kind of more aggregated data set, we see this curvilinear relationship where basically, so all the teams have taken our CI test, and this is the average here. And so we characterized all the teams with regard, because they were different sizes. So we, if they were all men or majority male or half and half, et cetera. And what we saw was that teams oscillated around average collective intelligence until they were majority female. And that's where we saw a consistent above average. In fact, CI is standardized to be a mean of 0 and a standard deviation of 1. So the average for the majority female teams was quite a bit higher than the average overall. But when we had all female teams, they were not consistently above average. So there's some benefit to having gender diversity, but with a tilt toward having more women. And I'll get into one of the explanations for that in just a moment. So we saw some benefit to having gender diversity. We also saw in a few samples a positive correlation between some level of racial and ethnic diversity. Although to be honest, we haven't had nearly the size of samples with a variation we would like to really dig into that. So that's an opportunity I keep my ears open for. And then cognitive diversity is another piece that we've looked at quite a bit, specifically cognitive style diversity. We've used a measure of different thinking styles that tend to characterize people who go into different professional domains. There's a thinking style that's predominant for engineers and people in more mathematically oriented fields, one that is more common in visually oriented fields, and a third that is more common in verbally oriented fields. And what we find, and this is my former student, Ashani Agarwal, who's done a lot of this work, when left to their own devices, that teams need to have at least a moderate level of diversity across those styles to reach the highest levels of collective intelligence. And Ashani's gone on to do some other work with collaborators, looking at how certain individuals who are strong in more than one style can be helpful in actually making this more of a linear relationship where diversity has a more continuously positive effect or association with collective intelligence. So cognitive diversity is another piece of diversity that we've seen that can have some benefits. A second category of things that we've observed relates to various forms of synchrony. So there's a kind of a diverse literature on synchrony, actually, but a lot of different bodies of research have looked at it as an indicator of sometimes cohesion, sometimes rapport, but really fundamentally about attention, where when collaborators are closely attending to each other, then certain aspects of their behavior tend to become more synchronous. And so we have seen this in a few different settings. But some of it is driven by this underlying characteristic that we've measured in many of our studies related to social intelligence, specifically social perceptiveness. There's a test called the Reading the Mind and the Eyes test, which asks individuals to respond to 36 items that feature a picture like this of the eyes. And to select from 4 options what the person is thinking or feeling. And I won't put you on the spot and make you answer this because this is actually one of the hardest ones that I just pulled out. If you're thinking playful, that's the correct answer. If you're thinking irritated, that's the most common wrong answer. But for a moment, just connecting this back to when I was talking about the gender effect and the proportion of women in the team, it turns out that women on average score higher on tests of this ability than men, and teams that have a higher average score tend to have higher collective intelligence. And so that is the reason why, or one of the reasons why we see this correlation between proportion of women and collective intelligence. But what this ability is really tapping into is the ability to pick up on subtle cues and draw inferences about what others are thinking or feeling. And it doesn't only pertain to facial expression, it actually is something that crosses modes of communication, tone of voice, body language, even text-based communication. So in some of our studies, we've looked at the correlation of this ability and collective intelligence in teams collaborating online via text chat. And we find that actually it's just as strong a predictor in that setting as it is in face-to-face settings. So it's really about picking up on subtle cues and drawing inferences about what is underlying it. And when people have this ability in greater quantity, it tends to help them facilitate a variety of social interactions. They notice, oh, you haven't spoken yet, or do you agree with what we're talking about? Or, you seem to not agree with what I just said, and all kinds of cues like that can be useful for enhancing collaboration. So having the social perceptiveness is useful for collective intelligence, in part because we also find that it enhances synchrony. So in an initial study exploring this, we found that dyads that had higher social perceptiveness were more likely to establish facial expression synchrony as they were collaborating. And if they did, then they had higher collective intelligence. And this was found even in dyads collaborating online using like video. It wasn't Zoom at the time, but using video conferencing. And then we followed up that study to look at dyads who were collaborating but didn't have access to video. And what we found was that for all dyads, there was also a certain amount of vocal synchrony where the qualities of voice like pitch and how fast they're speaking, et cetera, would synchronize over time. And the video actually seemed to interfere with that. But that ended up being an even stronger predictor of collective intelligence. So the Zoom people were not happy to hear that. But that was a follow-up to that. But both of these were also associated with having people in the team who were more socially perceptive. You tended to generate more of this synchrony when people had more of that ability. So the second piece of this, in addition to having diversity in composition, is having individuals in the team with some level of social perceptiveness that sort of manifests in part in the synchrony of behavior among collaborators. And the third set of things that we tend to find consistently associated with collective intelligence are all behaviors that signal engagement. And so a major one is amount of communication. What we see is that groups that communicate more and also more equally, such that you don't have one or a few people dominating the conversation, tend to be more collectively intelligent. And when you have teams that have more socially perceptive individuals and more women, it tends to correlate with this communication and equality of communication behavior. And again, this is true even when groups are communicating online and via text chat. The same patterns seem to manifest where more equal communication and more equal contribution to work products foster higher collective intelligence overall. So this engagement piece is another part. So as we've started to really develop more of a conceptual framework for how we think about how these things fit together, we've noticed parallels with, the functions that, variables like these seem to be performing, and basically the underlying functions in intelligence systems more generally. So for example, we know that memory is a really sort of core feature of any system, especially an intelligence system. And so we know that who's in the team, what skills they have, and the degree to which team members know about and use these skills and knowledge is an important part of collective intelligence in human groups. And that comes from the memory. The second function in an intelligence system is attention. So sort of deciding, what will be, the thing we're doing now, or how are we dividing up and doing different things and allocating our attentional resources in a way that aligns with what's most valuable to us as a collective. And so we see that many of these things seem to be signals of a group managing collective attention. And then finally, reasoning. What is it we're trying to accomplish? What is the most important? Are these things that we are all aligned on and motivated about? And those things being both drivers of and signaled by some of the behaviors that relate to engagement. And so what we see across the literature is that these essential functions of intelligence apply, whether we're talking about intelligence in individual brains or in computers, as I've mentioned, or in groups of people, we would argue, or even groups of humans and computers working together, that somehow these functions need to be handled to enable intelligence to emerge. And so those are sort of some basic concepts that we're now working with in our newer projects. And in the first one, as I mentioned in the introduction, we're really looking at it more from what you might think of as a psychometric perspective. Do these three functions show up in recognizable ways in our measures of collective intelligence? Can we actually segment these into measures of these functions? And so in a paper I'm doing with my collaborator, Chris Riedel, and a postdoc of his, Eric Como, we've been exploring our accumulated data from over 1,300 groups who've taken now our collective intelligence test to see if we see evidence of these factors in that data set. To kind of cut to the chase, we did explore the data, and we do find support for a 3-factor model where we can segment the different kinds of tasks that teams are doing into things that conceptually seem to capture these collective memory, attention, and reasoning processes that we theorize are important to collective intelligence. And in the literature, when you try to publish a paper like this, they always want to say, well, how does that compare to other models? So this is our chart sort of summarizing some of the exploration. So we theorized a model that would have the 3 factors, and the fit statistics for that are much better than if we just have a general CI factor. If we segment it into 2 factors, if we randomly segment it into 3 factors, we still see that the theorized 3-factor model is a better fit. We also looked at the fit of the model by segmenting our sample based on some characteristics. So this is the whole sample. But if we look at some of our teams were sort of established ongoing teams, while others were brand new, we just brought them into the lab for our study, versus some where I just pulled out, we had some that were working remotely. And what is interesting is that the remote teams, the model fits, pretty much just as well as, for the whole sample. The only place we see a slight decrease in the fit is when we're looking at brand new teams, which makes sense because if it's just a short-term team in a lab, it's a bit harder to capture the emergence of these functions, in that short period of time. Is that a question?
Yeah. Sure.
That's good, because then I can take a pause and take a drink of water. So thanks.
So why 3-factor model in context? Where why did you choose 3 factors specifically? And then you are using chi-square test here. So is that good for this analysis?
Yeah, so I'll give you I'll answer your first question first, and then I'll give you what I'll call the 4 dummies answer to the second question. But the first question was why the 3 factors? And the 3 factors are really driven by our concept that these are the 3 things that are the underlying processes that enable intelligence to emerge in any system. So that's why 3. And we went through, kind of conceptually the tasks we had and thought about which ones, or really even aspects of tasks, because some of them have multiple measures that you can capture, would be related to each of these functions. And so that's why the 3. And then in terms of the fit statistics, if you've spent any time perusing any of the journals where people are just interested in measurement in psychology or education, there are about 50 different statistics, and the ones you use depend on the ones that your reviewers like. But chi-square here is really gauging how well this model fits the data. And so you want it to be smaller because that means it's less of a departure from, because it would be 0 if it was a perfect fit. And so that's why the better fitting model has a smaller chi-square, but it has a higher, I don't know. I could wave my hands and say more about these things, but there's a lot of different fit statistics. And a lot of times it's about how big is your sample? How many factors are you capturing? What are the underlying errors, blah, 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 that determine which one is better. Yeah.
So a follow-up question on this. So for your three-factor model, so you have a collective attention. Was synchronicity a necessary condition for the collective?
So theoretically, we would say yes. Well, and actually, empirically, we would say yes. Not based on this analysis of this accumulated data set, but based on other research we have where if we manipulate things that affect attention, it affects those behaviors, including synchrony, and shows up, in the ways that we would expect. But this is the kind of thing where it's really going to be, you're probably never going to have the perfect study that tests the whole process for all of the factors at once. It's going to be more of an accumulation of different findings. And so that's kind of where we're at now. So we have some data that show if we manipulate attention, it affects synchrony. And we have, in those studies, synchrony then affects collective intelligence, in the ways that you would expect, both empirically and conceptually. None of that.
So in terms of measure, there are different measures.
Yes. So synchrony, like when we're measuring this, this is our CI battery, which is a set of tasks, kind of like I mentioned in the beginning when I described our original study. We have a set of tasks that the team does together that theoretically we, we're hypothesizing capture underlying processes related to attention, but they're just doing those tasks. We're not measuring synchrony per se. Synchrony is a behavior that seems to be correlated with teams that have good collective attention. And that we know from other experiments where we manipulate it more directly. So they're conceptually related, but we don't measure synchrony here. Finally, I got to what you're actually asking. All right. Any other? I'm pleased you're interested in this because I wasn't sure if this crowd would love to hear about the psychometric analysis we did. So happy to talk more about it either now or later. Yeah.
I was wondering about the sort of psychometric framework.
Huh?
So you also talked about individual intelligence, to start with, right?
Mm-hmm. And that has, that has 100 years worth of debates about that. Yeah.
But if you go back to the this one.
Okay.
So this one suggests to me visually that you think of collective intelligence as like a latent factor that causally influence these. And I think that seems sort of unreasonable, the strong interpretation seems unreasonable that there is like a thing, like for individual intelligence, right? Some have posited like neural firing rates or whatever, right? I mean, all of that is like,
yes,
something you shouldn't get into because it's
dangerous. No, I mean, there was
like,
a lot of debate about what, chicken and egg and what is the
exactly.
Mhm.
But there could theoretically, it seems reasonable that there could be some underlying actual entity in the world that caused these things to sort of cluster, like let's say visual and spatial and like different intelligences, right? But here it seems to me more that it's sort of a parsimonious description, like we have these different things, collective memory, collective attention, collective reasoning, right? But it's unclear to me what the real entity would be, like the collective intelligence. Like, is that an actual thing in the world? Or is that just a good sort of?
No, I mean, I think our accumulated evidence, but again, it's really a hypothesis still in some sense, right? But our accumulated evidence does suggest that there is this capability. Exactly what causes it, is I think just like what causes intelligence, in individuals, right? I mean, there's lots and lots of theories about it. But also I think one way that the psychometric approach doesn't quite capture the way we think about it is we really think about it as a complex adaptive system, right? So which way does the arrow go is in some sense what you're asking. And so it's, so we do, for example, see variation in collective intelligence in teams in a very short amount of time who are strangers to one another. So there is something, right, that seems to formulate that ability quite quickly. And it's probably some of the individual capabilities I mentioned earlier around social perceptiveness and diversity and, some of the inputs, right? But exactly then, how much that helps form these underlying collective cognitive systems, which then enhance or not collective intelligence in sort of a non-linear way. I mean, I think that's sort of the.
I think what I'm asking is, so one model you could have collective intelligence and you could have the arrows pointing to each of the three factors. Another model, you could have the arrows between the three factors, so they mutually reinforce each other.
Right, right. And I think
that would be the network.
I mean, here I'm kind of just showing you like the but this is more of our conceptual model.
So you have
in terms
both,
of how
okay.
and so, and actually I'll be building on this in a moment with an even more sort of detailed thing. But yes, it's kind of more of a interconnected system.
Interesting.
And exactly
yeah,
where the loop starts is probably not the same always. And I don't know if we'd ever nail that down.
Yeah, I just thought like in psychometrics or like latent factor modeling, usually when you condition
Yes.
on like the latent factors, they're independent, the observed factors.
So the
you sort of
statistical
have both.
models we're using are identical to other interpretations that
Okay,
can
interesting.
make that. Yeah.
Okay.
Yep. So until, maybe there will be better ways to capture it as we move forward that don't assume that sort of directionality. Okay, so actually, as promised, as we're sort of evolving, as I was saying, our sort of conceptual basis for how we think about the development and emergence of collective intelligence in a system, we're really kind of building on a little bit of the existing literature on transactive systems theory, especially I think it's been most well developed with respect to memory and most well developed like in the building that I sit in. So I have to talk about Herb Simon and I have to talk about transactive memory systems. Like those are the two things that come up a lot in talks around our neighborhood. But as we think about it, I mean, to the point, I think in some ways that was, we were talking about a moment ago, it starts with individual cognition, right? You have individuals who come into a collective, they have their own attentional focus, they have skills and memory that they're bringing, they have their own goals. They also have their traits and their emotional, system, whatever state of mind they might be in coming in, which we haven't even talked much about that yet. But, clearly that is the starting point, in most cases. But then theoretically, what we're saying is these things come into the system and are combined through these transactive processes. You have this capability, say it's memory, and what we know from the research on transactive memory systems is that if a collective is good at memory, at managing this collective capability, they can then store and use much more knowledge than they could otherwise, right? So a well-functioning transactive memory system evolves because, we each pick up on, who knows what and who's good at what, and we get really good at, crafting some specialization around that and encoding and then being able to retrieve it quickly so that we can be more effective collectively and use that capability. And so theoretically, this is what Pranav's thesis was focused on. Funny, it's focused on focus, on attention, how the same sort of system can be used to describe how collectives manage attention. We have this collective capability to focus on things. We can make decisions about when we're going to come together and focus on the same thing at the same time, when we're going to divide up. The timing of that coordination is also a piece of this. And so it's through these interactions that we start to develop a way to manage that system. And then similarly, there's other work on transactive goal dynamics in the psychology literature, but here we're building and extending that to talk about transactive reasoning systems, that people come into a collective with their own goals, their own motivations. And so through a series of negotiations, the collective determines what we're going to do. And the degree to which individuals see their goals as being aligned and satisfied by staying in the collective, then they will remain committed and put forth effort. And if they don't see that alignment, then they will probably leave. And so these three systems, kind of evolve. And even though I'm describing them in this very explicit, intentional way, what we know from, a lot of literature is that a lot of this happens without people sort of explicitly recognizing that these processes are going on. But theoretically, this is what we increasingly believe to represent what takes place. And then we are, conceptually saying that manifests in a variety of behaviors, collaborative process behaviors that we can observe, that an observer could use to get a sense, because you can't see this, it's happening under the hood, but you could potentially see this as sort of a clue to how things might be operating. And so these systems are important to evolve and sort of manage each other as they support the emergence of collective intelligence, because when you have the memory and attention system, this is really what we think of as the production function, right? This is how stuff gets done. Who's doing what? Who's the best person to do what? Okay, is there a big bottleneck here because we're waiting for the expert? Maybe we have to look at who's available to take over, et cetera. And so there are decisions that are made between those systems as well as within those systems. And then the transactive reasoning system performs the maintenance function around both making sure we're pursuing the right goals, but also are our goals aligned so that people will continue to work with our group and stay happy about it. But we're really here now when we get into the realm of how do we detect collective intelligence, thinking about these observable process metrics. And so that's what is involved in the other project I'm going to tell you about. Yes.
So you also mentioned this that at times of like when the goals don't align, then they might just leave from the team. Like people might just leave the goals don't align.
Yeah. So I think so I would say this is. There we go. So I would say, that bit of it is really something we're drawing from existing literature because, for example, in open source projects, you see a lot of turnover. And so and there are a lot of organizations now that are seeing a lot of turnover. And we know that a big driver of both effort and commitment at the individual level is goal setting and goal clarity, but at the collective level, whether you're talking a team or an organization, is goal alignment.
Would you say that that is the necessary and sufficient condition for something to happen or not that?
For somebody to be what, happy or not happy?
Like that the team would be intact or not? This would be necessary and sufficient condition.
So I think it's a major condition. Is it the only condition? So you mean for team viability, basically? Yeah. I don't think it's the only condition because I think there's certainly, I'm talking about alignment and people being committed, but then we have, some of the individual level factors, around affect, around people developing their personal skills and things like that, that also affect team viability. But here we're looking at the collective.
Them as factors here. So that means only these factors component. Like not just goal setting, like all the other factors that you have on the slide could also be sufficient condition.
Oh, for a team to remain viable? Well, actually, I think I'll invoke Pranav. I think he's on Zoom, so maybe I'll just cold call him in a minute. But what Pranav did in his thesis, which was very cool, is he did an agent-based model showing actually that you really do need all three of these systems, because in fact, you can see dysfunctions when a collective is relying too much, say, on transactive memory. It's like, okay, it's all about expertise and that's it. And we're just kind of, something comes in, we put it together and we just wait. Or if it's all about attention, we're just doing everything really fast, maybe not very good, but we're very efficient. Or it's all about what we want. And if the world is aligned with what we want, but maybe the rest of the systems aren't functioning. And so theoretically, and what his model showed was that you really did need all three systems to be mutually regulating, to maintain collective intelligence over time in a changing, complex, dynamic environment.
This would depend on your sample or the template.
Well, this sample was an agent-based model, so there are assumptions, of course. Certainly, there would be things about the environment that would make a difference. So if there are, certain kinds of things that are not very dynamic or complex, well, then there would be less need for, the components of the system that would be more critical in an environment where those were a bigger deal.
Thank you.
But that's the kind of thing that collecting the data to really test all of that. If you find that setting, let me know. Because that's what's that? Well, thanks. It's Pranav's work here. I don't know. They can't see you. I'm sorry, Pranav, but I can see you. I'll put you on the screen maybe after. because right now you'll block my slide. Okay, so I'm trying to get back over here so I can advance my slide. There we go. All right, so collaborative process metrics. So I mentioned that, those things at the top, the knowledge and skill, et cetera, are the things that we posit are the observable indicators of the underlying function of the system. And so use of knowledge and skill is the team figuring out who knows what and putting them in the right roles. Things like task strategy, are we being really efficient in how we're getting things done, or are people redoing things or other people are waiting while somebody comes because it needs to be 2 people doing it, or things like that. And also effort, are people, is the collective effort sufficient and high, and are people, in some cases, we're also looking at, are they staying? But in the examples I'm going to give you here, we're really looking at more about effort and collective effort. So in this second project, this is an illustration that is part of a project we're doing in a DARPA program called ASSIST, Artificial Social Intelligence for Successful Teams. And so the goal of the project is to really find ways to detect the quality of collaboration with a goal of developing agents that might be able to intervene and help teams perform more effectively. And so the test bed environment for this project is Minecraft. And the game is structured as a search and rescue task. And in this particular version of the study, there were 3 roles that were part of the mission. There's medic, a transporter, and an engineer. Oh, here, let me show you. This is like an overhead animation of one of the teams in the data set. But basically they are in a building, they go in, they have to triage and rescue victims in a fixed amount of time. Each role has certain capabilities or things that they can do better than the other roles, or they're the only person who can do it. There are places where people get stuck and they have to be rescued by their team members. So if they get into a room, the others have to come, they get frozen, for example. Some of the victims to be rescued or triaged need more than one of the team members, like the medic and somebody else, to be near the victim in order to be able to administer to them. And so here we're really looking at whether or not we can capture these real-time collaborative process metrics to be able to diagnose if the team is going to perform well as collectively intelligent. And then we're looking at that in relationship to the actual performance scores. And so to get more specific here, when we're looking at knowledge and skill, we're looking at how much is the team really making use of the unique capabilities of each member versus, like, even though the transporter can move around a lot faster, is the medic slowly trudging around to try to find victims instead of triaging victims and letting the faster person go around. That would be just one example of the ways that they needed to coordinate their skills to perform at the highest level. Task strategy, are people covering new ground, or do we see people covering the same ground a lot? And so over time, are they efficient in completing their work and triaging the victims, over the course of the mission time, or are they not very efficient at doing that? And then finally, effort. And here, in some teams, people might just be standing because they're not sure what to do or where anybody is. Sometimes actually there might be a lot of effort, they're moving back and forth, but they're not actually doing tasks that are related to their role. So we're capturing amount of effort as well in real time. And so to do this, we were using the underlying data that's captured as the teams are working in Minecraft and calculating each of these metrics. And initially we were tracking them over time because, again, as I mentioned, we're trying to predict when is a team getting into trouble and what kind of intervention would be helpful at this point. And so using these inputs as ways to inform that sort of diagnosis was it has been our goal in this program. So just to kind of show you a more of a concrete demonstration here. So they're come in, they're trying to find their victims. And as you can see at first, the metrics are kind of, looking pretty good, but now effort is really high, but these other two have kind of dropped a bit. And you can kind of see they're running back and forth a lot, but they're not very coordinated in how they're going about doing their work. And so over time, I mean, that just kind of gets a bit worse and worse as you watch. And this is actually a pretty common scenario, especially when you have individuals, because it turns out being able to navigate and have spatial orientation in this first person perspective environment. Because if you haven't played, probably most of you have played Minecraft, but this isn't what the players are seeing. They're seeing more of a first person thing where they have to figure out where to turn and where they've been before and not get lost. And some people do get lost.
So what is the Y value measuring there?
What's that?
What's the Y value measuring there?
Oh, well, these are whoops, sorry. These are standardized. This is just these are standardized. Each of the metrics are standardized within, the range of the data. And what we've been playing with over time is what the threshold should be, below which you start to get concerned. But essentially, they're all standardized so that they're kind of moving up and down on a similar scale. I mean, I forget exactly what the number scale is, but
Like standardizing, like we take the sample, we get the values, then we standardize that one.
right. So this is something where, we spent quite a bit of time studying, what's relevant in this environment and figuring out a way to capture it on some sort of a scale. And that tends to be at the stage we're at, it tends to be true in every study we run. We don't have just like a general.
So did you develop an adaptive threshold? Adaptive threshold.
Did I?
Threshold updates itself as with time.
Oh, well, no, not yet. I think that's definitely a goal, but I'm looking at because he knows about another project we're doing. But we are doing right now when we do a study, a lot of times we do pilots and we establish the threshold. But I mean, I think the goal would be what you're saying, because you have, well, actually, another piece of this that I didn't get into is we also have tried versions where we measure a bunch of stuff about the individuals, because there are things about the individuals that influence what the starting point even would be, such as ability to navigate would be a big one in this case, right? So we tend to make these sort of specific to the environment at this stage, because we don't have the ability or the model yet for exactly what we'd have to capture and how to incorporate it in real time. But that would be pretty cool. Okay, so let me, so just to kind of, I think, reinforce a point or I guess illustrate further a point that I mentioned earlier, we identified these behaviors based on a meta-analysis from our larger data set of teams taking our collective intelligence battery. But just to sort of confirm in this environment that these observable process behaviors seem to be indicators of this underlying and sort of ongoing capability. One analysis we have been working on in a paper that's under review now is we take these behavioral process metrics and we do see that, metrics captured, at one point in the mission predict performance slightly later in that mission. Then that performance actually predicts ongoing behavioral metrics, later in that mission, and then the performance at the end of the mission predicts the behavior we see in the next mission, et cetera. So there seems to be the kind of theorized relationship that these behaviors taken as a whole are capturing this underlying capability, which here manifests also in performance, and those things seem to work together synergistically, over time, suggesting that capturing these behaviors is telling us something meaningful, about what the status is of this collective, and maybe, to figure out if there's a collective that is struggling. Another variation on that kind of an analysis was done by Michelle Zhao, who works with Henny Edmonian Robotics, where she actually developed hidden Markov models. So using these behavioral process metrics, capturing, the current state of the group, the team, and then using it to look over time at the prediction of what state the team would be in the next phase. And as you can see in this matrix, that kind of shows you the correlation between where they are in state and, at one time point, and then the next time point, you don't really see many groups go from being in a really poor state all the way up to being great. I mean, they usually progress to sort of adjacent states, suggesting that if we had an agent that was using this to reason about what it's observing in a team, it could probably draw reasonable inferences, even based on what we have now, about a team that is doing well, getting better, versus a team that is starting to sink and probably could be helped with some sort of an intervention, ideally guided by observations of which of the metrics seem to be really a point of difficulty for them. So that was just another view on the same idea. So as we sort of develop these things more, we see sort of different levels at which we would conceive agents being useful for enhancing collective intelligence. I mean, already, I think a lot of us use assistants anyhow for our individual memory, attention, and reasoning. We could also, and some of our collaborators in the DARPA project certainly are looking at agents initially as being assistants to individual team members, noticing the team member who's getting lost and helping that team member do better. And so helping the team do better because this person's skill level is enhanced. But then as we start to think about it more at the collective level, what are the different kinds of interventions we might make that would enhance collective intelligence? And so one version, actually in a paper that we finally have accepted at MIS Quarterly, looks at nudges to help enhance collective memory, attention, and reasoning processes. And I'll just, sort of ruin the punchline. It's harder than you think to nudge these things, because doing things that disrupt the collective dynamic is easier than doing things that enhance it, is kind of what we were finding. So we found one nudge that was helpful, but others that had unexpected effects. And then finally, I think what I was illustrating to you a bit in the last little video clip is the diagnosis piece, but ultimately moving to a place where, could we conceive of having almost a management function where, there might be an algorithmic teammate who's helping enhance the coordination of members based on what is being observed about their collaboration.
So here nudge could be disruptive, right? But how about designing nudges such that they are not disruptive, they don't cause harm, but if they help, otherwise they don't.
Well, I think one thing is, as we get smarter about what the cues are, we would get better at making nudges be deployed in a more sensible way than was true back when we did that study initially a couple of years ago now. So that would be one, would be to kind of get better at the diagnostic piece of it. But I think it's a very subtle, anything with these kinds of interventions tend to be pretty subtle in terms of when it's administered, how it's administered, what else is happening in the team, and if they're going to be receptive to it. There's actually, in the team's research literature, there's a whole body of work, and I think it's growing again, on just the sort of form and function of delivery, aside from content, in terms of how that affects the way a human collective responds. So I think there's quite a lot to that. But one of the inputs that could definitely be improved from the time we did our initial study is even the reasoning about when to do it or what to do specifically. Yeah.
Just a suggestion that there are a lot of distributed teams now, and when you do tasks collectively in a physical environment, you could actually observe a lot of things, like whether or not someone is slacking and doing nothing, or how well, you have a lot of transparency. But now, since a lot of people work from different locations, we don't have as much information, and maybe it's just one of the way where AI can help, because for example, on GitHub, you could see actually this activity kind of how many edits person submitted there.
Yeah.
And it's super helpful, and also like super helpful for yourself to see, oh, it looks like I didn't do much.
Yeah,
all that
yeah.
time.
Well, so interestingly, so the study I mentioned, I should have put the site here because it'll be published soon, I hope. Yay. Well, some of these papers you like, it's almost like you gave birth by the time. But it's these were all distributed teams that we did the study in, and one of the nudges that we thought would be really effective was to show everybody how much effort each person was putting in, and it totally backfired.
Oh, wow.
Yeah, it
People
sounds
were really,
brilliant.
yeah, it was like they, yeah, people thought they were manipulated. It was like too much pressure. Yeah, so that was one of our lessons because we thought, oh yeah, sure, everybody's worried that people are slacking off. But you know what happened was the people who were working really hard got mad and they stopped working as hard. The people who were being called out for not working, they got mad too. And so everybody just kind of, yeah, it was a significant negative effect.
So would you call that an attention? Like what does that nudge? Which of these three?
Oh, so the actually the one that was about effort was really more of a reasoning system nudge. We were theorizing because people are observing what their team members are working on and that their team members are working hard, and it influences their own reasoning about how hard they should be working and what effort they should.
It's not like actually reasoning about the task, but sort of meta reasoning about.
Yeah, I mean,
Yeah.
that would be another level of nudge potentially, like, oh, should we be doing something else?
Yeah.
Or are we all on the same page? This one was a lower level of like, how much effort am I putting in here and aligning that across the team? Yeah. Okay. Well, this is my last slide, so I hope you have more questions. So just to kind of summarize, because I've sort of meandered through a bit of an overview of a few different projects, but circling back to our original inspiration here, and reinforcing the idea, which is maybe an idea that's not something I have to argue hard with this group about, but sometimes in the business school environment, we think about organizing, either an organization or a team for specific objectives and optimizing their processes for those objectives. And what we're pointing out is that given all of the complexity that most groups and organizations face, that way of thinking about performance is probably outdated, and that more collectives should be really designed to have very robust underlying collective cognitive systems that would enable them to engage in their own reasoning about when maybe, oh, the signs say we should kind of shift slightly what we're doing, or maybe our strategy for how we do it, or even as an organizational system, we should be set up that way. And it might look quite different than the traditional organizational designs that we think of, but maybe better suited for this complex, distributed, dynamic environment. And so really what underlies that kind of a design is, these three transactive systems I've described, and setting those systems up to help give people the inputs that they need to mutually adjust to one another, to know about the knowledge and skills, or the focus of attention, or to negotiate goals, for example, to maintain the functioning of the system as a whole. And so toward that end, our more recent projects are really trying to identify, and I think this is an ongoing process of identifying what are the observable indicators or observable from an algorithmic perspective indicators of how these systems are functioning, so that we might detect as soon as possible when there might be things getting off track. And then a whole other set of interesting questions, I think, to explore around how you intervene to try to improve the system. So that's my story. I'm sticking to it for today. Thank you very much.
Okay, can I have a question?
Sure.
At the beginning, you mentioned that diversity and synchrony contributes to collective intelligence. And I keep wondering, diversity and synchrony of what? Because I can imagine a diversity of values, and this probably wouldn't help in achieving collective intelligence.
Well, yeah, that's true. So in some senses, that kind of a question. Pull up something. So there's, each of these has its own whole literature, right? So there's a pretty broad literature on diversity. And based on that in combination with some of our studies, you're right in the sense that diversity in values, in some cases can be problematic specifically for actually achieving goal alignment.
Yeah.
But diversity in other forms, and I think some of the ones I highlighted, such as thinking styles and so on, can actually bring, more perspectives. Those also tend to be associated with other skills and other knowledge bases that can be useful in a variety of different team environments. So it's certainly not the case that like diversity of whatever, is beneficial, but for the most part, the general conclusion has been diversity that enriches the knowledge and skill base of the team, especially in ways that are relevant to the kinds of goals they're pursuing, would be beneficial.
I think I could see now that synchrony, you mentioned that it's like cooperative norms. So it's like synchrony of norms, it would be kind of synchrony of values probably also. Yeah, maybe.
Although I would say that this sort of synchrony, so the social perceptiveness piece in this is really the capability that individuals are bringing that lead them to be more attuned to the signals of others and to foster this interactional synchrony. And in one study with another student who's actually a faculty member at Heinz, Anna Mayo, we tinkered with that by creating competition within the team, which disrupted the collective attention and the synchrony. That was one of the experiments where we kind of did that in a more, causal sort of form. And so that's where we saw that breakdown.
Yeah, may I ask a question?
Sure.
Yeah, so I'm wondering what does the drawing the communication or the eco communications means in the environment. Where people have their unique skills. So I'm kind of wondering, like as a manager of a team, is it better to design the task is divided so that every people can have equal communication with each other, or it's better to utilize everybody's unique skill and make them do their own stuff?
Well, so I guess that using your unique skill and do your own stuff would assume that there's not a lot of interdependence or need for coordination. And if there isn't, then there probably isn't a lot of need for communication. So maybe one thing to clarify with that general pattern. If you have a diversity of skills in a team and those skills are needed in order to accomplish the goals, well, then there's no one person or group of people who knows everything. So overall, the course of the work they were doing together, you would expect that each person would have to contribute something in roughly equal proportion, let's say, all right, even though there may be some caveats with the work itself. That doesn't mean in every given moment it's absolutely equal, because, for example, when we have our battery of collective intelligence tasks, some people know more about some than others. And in fact, the people who do know more should talk more in those moments. But if you have a diversity of tasks such that different people are going to know different things that are relevant, or maybe there are some tasks where it's not so much about specialized skill, but it's about everybody contributing. What this results in is that overall, across the course of the work, having more equal contribution and communication is going to yield better outcomes than, for example, an all too common pattern where one or a few people do all the talking. And sometimes it's the leader. And that's where when people ask me, well, doesn't it matter if you have a leader? And it's like, well, the leader enacts their role by doing all the talking, then it's not that beneficial. But if what they do is facilitate the contributions, then it is. But I don't know if that, so if it's interdependent work, you would do better to have them work together. And if they have the diversity of skills needed, then you'd see over time at least roughly equal contribution.
I'm curious kind of about some of the maybe boundary conditions of this sort of work. So a lot of teams these days have very permeable sort of boundaries, right? People are members of more than one team, maybe several teams, maybe a lot of teams.
Yeah.
And also in a lot of workplaces, the work is more asynchronous. People aren't necessarily getting together as a team. And
We're actually really interested in that, but yeah, please go ahead.
I'm just wondering, you know, what does collective intelligence look like? Is there in that kind of environment where it's more of a network than team?
Yeah.
And so on.
So I would say, I'm just gonna pull this up as something to refer to. So I would say theoretically, you know, how the systems would evolve and affect the collective intelligence of the team would be the same. It's just that when you have turnover, for example, you know, it obviously disrupts some of these systems. And so exactly how you deal with the, you know, the interchange of members so that the system isn't completely disrupted every time would be an important question in an environment where you have a lot of turnover. So I guess I refer to open source projects because maybe that's something we know in common, but the better run ones are those that have structures to try to handle, you know, that turnover so that you don't completely disrupt the system. Asynchrony is also an interesting question. So some of the teams in our larger data set operated in a more asynchronous way, but I think we're really interested in knowing, you know, what do some of these things look like when people are not communicating, you know, in real time, and how do you actually foster them? So certainly synchrony, well, the synchrony piece that plays out there that we've seen in a few studies, we've seen this pattern we refer to as burstiness, where the teams that are more collectively intelligent, they not necessarily are synchronous all the time, but they're synchronous in very, you know, specific and focused periods of time. And in the first study, we observed that it was in a software programming contest where the teams were distributed around the world. So they were very different time zones. And the more successful teams naturally sort of evolved into this pattern of burstiness. So they just figure out like when the other people are online, and that's when they get on and they, you know, send each other their questions and so on. And then in between, they'd be kind of working on their own pieces. So I think that the manifestation of some of the patterns is obviously going to be different, but I think conceptually, the systems that are important are the same.
Towards the end, you discussed AI assistants, and I'm wondering how you differentiate between an individual using a tool like a calculator, which you might just want to consider as an individual versus an individual using a tool like ChatGPT, which maybe you would want to consider that like a micro team. And maybe there's like a continuum of how complex the tool is. And maybe even in some instances, if it's like a senior researcher working with like an intern, maybe that's more analogous to someone using like a AI assistant at sometimes.
Yeah.
But like, how does that differentiate?
So there might be, you know, we haven't formally kind of, you know, put this into our, you know, in a written framework, but I would say the closest was that chart I showed at the end. When we are thinking about these different levels, it's partially capability of the tool, but also the focus of the aid, right? So at the individual level, so even ChatGPT would be primarily augmenting the individual's ability in that case to write, you know, which then of course would affect, you know, the product that they're contributing to the team as a whole. But whether they're using a calculator of their own accord or ChatGPT, or maybe a higher level of capability on the part of an agent would be, hey, it looks like Anita, you're really bad at adding. Here's a calculator, you know, to sort of like help augment my blind spots, if you will. All of those would be things that would be functioning at that individual level cognitive capability, but of course it then affects what the team does with each other. Whereas this level we're thinking of more as looking at the team level. So if you're say a sports coach, right, at one level, you're trying to improve the capability of the individual athletes, but then you also have a sense of what the strategy should look like and where the players should be positioned. And when those things aren't happening, the coach intervenes to sort of correct how the team is working together. And that's kind of how we see this one. Does that address the distinction? Yeah.
We designed an AI agent that considered this framework of your memory, attention, reasoning. Would that be an equivalent of a human in the team? And then we could actually they would play for the team. So like human AI team could have one human and one AI, which acts according to the framework.
Well, so there is kind of a growing literature on, human, autonomous teams, autonomous teammates, humans collaborating with more agent-based teammates. Some of that literature really does conceptualize the agent as a discrete team member with a specific role and a specific set of tasks. And, whether they would be this kind of omnipotent, can capture everything, or just be, have the specific capabilities like a member would, I think different variations have been used. Another way we've been thinking about it, which I think is a little different than the primary view that I think, is more captured by what you were describing, is not the AI as a teammate, but the AI as part of the context, right? And so, it could be a named agent or not. It could just be, you get on Zoom, say, and there's a set of capabilities, kind of operating that are changing either displays or things about the environment you're collaborating with to try to address deficits, that it's picking up in terms of how you're collaborating. Or it could be a dashboard. I think that's one of the strategies that in the DARPA project they're thinking about now. Like, what is the dashboard that you could give to the team members or to the team leader, that would have the effect of maybe causing them to change what they're doing or shape what they're doing in a more positive way.
And also in this framework, we are not considering emotions, human emotions.
Not explicitly, not here, but it's definitely, so I had a postdoc who was here until just this past fall, that was his focus, and how some of these things play out differently or are more important if people are angry, for example, versus being anxious.
And that,
Yeah.
that has a burstiness nature to it. Like emotions.
Maybe there's some people who are more trait-based negative affects. So that could have, you're right, it could be bursty or more of a chronic thing. I think when we think about those at this point, as I mentioned earlier, that could be part of the starting point, just understanding who's coming into the team and where they're at. We also have thought about, well, if we were sensing that in real time, how does that change the interpretation of the other things we're seeing? And so someday, hopefully we'll get a chance to really dig into that a bit more, because I think it will definitely be important. And then the question is, when we've had these debates in our team about it, it's like, okay, you pick up the emotion. Should the intervention focus on the emotion, or should the emotion be another input for detecting if things are going well or not? I tend to be in the latter camp, because I can't imagine, unless you're going to have like a comedian on the like trying to make people happy. That to me, I think that's going to blow up faster than our effort feedback thing and our study of the nudges. Yeah.
It's because emotion in itself does not have a metric.
Oh, it definitely has a metric. And there are, a variety of passive measures of emotion. What I guess I'm getting at is more what the intervention is. So I know you're angry, but then what does the agent do? Does the agent try to directly address the emotion, or try to reason about why you're angry and address that?
Like, as opposed to if someone had bad memory, then you can suggest that you can use this tool.
Right. Or you shouldn't be in that role because you have bad memory. So let's put you in this role and put the person with good memory in that role, if there's that distinction. Right.
No, I'm interested in in the nudges and the fact that they were more disruptive than not many
Well, one
times.
was good. So the one that was good actually was the one that was stimulating, I'd say the memory piece where it prompted the team to consider and even discuss who knows what as they were encountering a new task.
Yeah, and
That
I
was
was,
the
and I
main
was
stuff.
curious, were those nudges targeting different areas? Okay,
So this was almost like a proof of concept study. Like, can we actually stimulate a team to engage in things or adjust things that specifically affect these systems? So we had a nudge that was targeted, or at least one nudge, in some cases more than one, targeting each system, and then looking at how it affected the behavior relevant to that system. What time are we? wrapping up?
I think we can wrap up.
Okay.
That's the final question.
Okay.
Yeah.
because I can see being able to set up a study. It's like, say you gave the mind and the eyes test,
Mhm.
and there's like a 10 one
Yeah.
instead of a whole 30. If you gave that to individuals and it's like, you could separate people who scored high and low really quickly, like in Qualtrics, and send them to a different thing
Mhm.
and give them form a group of 4 that are all terrible or all great,
Yeah.
and give them a nudge targeted on that.
Right. And I don't know if I would do it on that basis per se, but that concept we've thought about, although I have to tell you, conducting those studies, I've conducted one study like that ever. I will never do it again. Like where you need specific people with specific qualities and oh my gosh. But yes, but hold on, let me just finish but I would focus it. Well, so one way I would do the pre-screen for that is not necessarily high social perceptiveness versus low, but making sure there's at least some amount of social perceptiveness in the different teams, but maybe more
Yeah,
on
you could-
skill.
Yeah, you could do that too. I mean, you
Yeah.
could either make them high, low, or mixed.
Yeah,
And if you just had a 10 question, say, intro thing,
yeah.
you could probably,
But it'd have to be a setting where you have a bunch of people and you can sort them. Yeah, that kind of a setup. Yeah, for sure. I think, okay, we gotta,
Yeah,
actually, I
yeah,
have to go
we
to.
can keep the other
Thank you
discussions
so
offline.
much.
thank you for coming.